Greetings and welcome. In this video session, we will study about the multi-stage refrigeration system. So we will first see where the multi-stage refrigeration systems are used. So when there is a requirement of low temperature, very low temperature, means below minus 30 degrees Celsius. In case of maintaining the frozen food inside the cabinet for some period, food preservation, and there are some medical applications also when there is a requirement of different temperatures for the different applications. Normally we see in a cold storage. In a cold storage, different products are stored for the different temperatures. So temperature requirement is different. In such cases, we have to use multi-stage or multi-pressure system. Now here, our regular system, that is a single stage vapor compression refrigeration system, that is not applicable. So reason behind that we will see here. So here we can see the example of split air conditioner. Split air conditioner is used for the domestic purpose, means for the home cooling. So where the size of the room is small, means about 12 feet by 12 feet, means about 100 square foot to 150 square foot. So in such cases, the cooling capacity is limited, that is about 1.5 ton of refrigeration. In case of car air conditioning also, here the 5-seater car, that is a passenger vehicle. So here also the capacity is limited, that is about 1 to 1.5 ton of refrigeration. Water cooler is used for the water cooling purpose. Here the temperature of the water requirement is 13 degree Celsius temperature, that is for the drinking purpose. So in such cases also single stage refrigeration system is enough. So here we can see the concept which is here, that is a vapor compression refrigeration system. Here are the mainly 4 components: compressor, condenser, expansion valve and evaporator, that is a cooling coil. So this system is divided into 2 parts: onwards compressor, condenser, this part comes under high pressure zone, and expansion valve and evaporator, that part comes under the low pressure zone. Especially in this system, refrigerant used is R134A, that is called as tetrafluoroethane. Its boiling point is about minus 30 degrees Celsius. In such cases, here we see. So in this case here, if we see performance of the system, vapor compression refrigeration system, so that is studied by using the diagram, that is pH diagram, pressure enthalpy diagram. Here we can plot the vapor compression cycle. This is a saturation curve we call. Left line, that is a liquid line. Right line, that is a vapor line. Here is a critical point. Here are the 3 zones: subcooled zone, wet zone and superheated zone. When the vapor compression cycle is plotted on this chart, pH chart, then here we can see process 1 to 2 compression process, 2 to 3 condensation process, 3 to 4 expansion process and 4 to 1 evaporation process. So here especially 4 to 1 process is a refrigerant effect of the system, what is received at the space to be cooled, and this is output 4 to 1, means H1 minus H4 in enthalpy form, the output of the system, and input to the system is what work done, which is consumed by the compressor in a process 1 to 2 process. So H2 minus H1 is a work. So here the COP means coefficient of performance of the system, that is a index performance, that is what ratio of this refrigerant effect, means H1 minus H4 divided by H2 minus H1, that is a work. Output divided by input. So this is what the concept of the coefficient of performance of the vapor compression system for single stage. Now when we see this for the multi-stage So normally in case of multi-stage, there are two types: multi-pressure system and multi-evaporator system. Multi-pressure system is used when there is a very low temperature requirement. So in such cases, here the regular compression is not enough. Here more than one compressor are required. That is why that system is called as multi-pressure system. Now in multi-pressure system, the pressure ratio is very high. Here we can see if we go for the multi-stage, then if we go for the multi-stage operation, means for heavy duty application, and if for that application if we use single stage system, then what will happen in that case? Here this compression 1 to 2, this compression is increasing to 1 to 2 dash, means here this condenser pressure is increasing, it is reaching to high. So that is why here what happens, this increased portion that is shown by the dotted line, here you can see 1 to 2 is a single stage compression, and when we use single stage system for heavy duty applications, then in that case point number 2 will be shifted to 2 dash. Simultaneously remaining points also will be shifted in upward direction, that is 3 dash will be condenser. So what will happen, effect of this 1 to 2, that line is increasing to 1 to 2 dash. So that is why here if you see the new work will be what, W dash. So W dash is a higher. Other way, if you see this 3.3 dash, this point is a condenser end point. So this is a saturated liquid point, actually it is an ideal point. So this point is moving from 3 to above in a above direction in this way. So that is why here this 3 dash 4 dash, this is a expansion process. So in that expansion process here flashing effect of the refrigerant is increasing, and it will reduce ultimately what, length of this 1/4. This is a white line 1/4 of single stage, and if we go for heavy duty application by use same system, then here we see this 1 to 4 dash. So 1 to 4 dash is a refrigerant effect RE dash. This RE dash is also reduced, means ultimate when we use single stage system for heavy duty application, then what happens, refrigerant effect is decreased and compressor work is increased. So ultimate effect is what, ratio of refrigerant effect to compressor work, COP, that is reduced, means performance of the system is getting reduced. So that is why here single stage system we if used for the heavy duty application, then we get this is what disadvantage of the single stage system or limitation of the single stage system. So that is why here what we do, instead of using single stage, we use number of compressors and we divide that system into number of envelopes, means VCC envelope, one above the other. Also another one disadvantage is what, if you see, we know that specific volume of the compressor, that is what actually m dot, mass flow rate and volume, because mass flow rate unit is a kg per second, this volume, specific volume is a meter cube per kg. So product of kg per second into meter cube per kg, kg will get cancelled, and this is what, meter cube per second, this is a volume flow rate. Now this volume flow rate can be obtained by using dimension formula, dimension volume. Meter cube per second is what, volume per unit time, and volume is what, this is a cylinder. So cylinder, this is a diameter, so area of circle, that is pi by 4 d square, and the displacement of the cylinder is a L, we call it as stroke length. So pi by 4 d square area into stroke length L, that becomes volume divided by time. So here this volume flow rate depends on the diameter of the cylinder and length of the cylinder, stroke length of the cylinder. That is what displacement of the cylinder means. When the flow rate is increasing, then what is going to happen, that diameter of the cylinder, means bore diameter of the cylinder is increasing, and it will increasing the size of the compressor. So that compressor size becomes bulky when there is a requirement of more flow rate, because more flow rate is required in case of heavy duty applications. Here we can see how the mass flow rate is required more. Here we can see mass flow rate is again ratio of what, cooling capacity in a ton of refrigeration divided by refrigerant effect. As we saw here, refrigerant effect is reduced for heavy duty application. When we go for single stage, then definitely what happens here, when this denominator is reduced, so obviously mass flow rate of the refrigerant is increasing, means we have to circulate more quantity of refrigerant through the system, throughout the system. So these are the some limitations of the single stage system when we go for the heavy duty applications. So to handle more refrigerant by the compressor here, and again to avoid the problems what we discussed now, here are some options available. Which are these options? First is what, intercooling between the successive compressors, because we know that when we use a single compressor, then pressure ratio is increasing. At the end of compression, there is a superheated vapor. So that superheated vapor enthalpy is also more. That point is moving in a right side direction on the pH chart. So it is increasing ultimately work also. Means after the compression, such compression, we have to remove that heat, that enthalpy. We have to reduce that enthalpy. So for that we have to do intercooling after the compressor, and then that refrigerant, cooled refrigerant, we can pass to the next compressor for the next operation. In this way we have to use number of compressors in the system, and such system is called a multi-stage compression system. Again, their second concept, that what we discussed, left side of the PL diagram, what we saw here. Here, if we go for the high pressure ratio, then what happens? This dashed line, this line is having more flashing effect. See here, 3 to 4. This is regular, and 3 dash 4 dash. So here we find more flashing. Now flashing is what? When the refrigerant from the condenser line, liquid refrigerant, is passing through the capillary tube, that is a expansion throttling device. In that, here what happens? Partial conversion of the liquid is taking place into vapor. This effect is called as flashing. In turn, remaining liquid refrigerant temperature is getting reduced. As this process is a throttling process, that is called as constant enthalpy process. Here the temperature of the refrigerant is reduced, because here the simultaneous part of the liquid refrigerant is getting converted into vapor, and in this conversion phase change is taking place. During that, temperature is drop of the liquid refrigerant. That liquid refrigerant we are using in the evaporator. So when the flashing effect is increasing, then it is reducing this 1,4 dash length. Means this is what effective refrigerant effect means. We should not compromise to the cooling effect. So for that purpose, here instead of single stage, we go for the multi-stage. So here what we do, we can remove the flash gas. So for that purpose, there are some systems that we will see in a further video session. Flash gas removal, in that we can continue the process which is onward the condenser, that is capillary tube. That process means expansion process. So here we find this 5, 6, 7. This is a expansion process. So in this way we can overcome the problems which are occurring by use of single stage system for heavy duty applications. Now we will see in a detail in a further session different types of multi-pressure and multi-evaporator systems.